All right, how's it going? Going well, good. Questions other than ODP 410, because I'm going to talk about ODP 410 extensively after questions. Or questions about ODP 410, actually. Yeah?
Do you know when we're going to do our SLC draft?
Oh, I will grade them sometime before Monday. And I take a long break to go through those. Other questions? Everybody sign up for a lab group and send me an email and tell me your group number. There's 20 people who haven't. They must all be in the other section. Or they're not here. All right, let's talk about the ODP. So ODP 410 is different from the others that you've done so far. And it's probably going to be the trickiest one to do because it's different from the others. But it's really how these ODPs are going to work for most of the rest of this course and for CSE 222. So ODP 410, you're writing a function. You're not writing a main program to assess. You're just writing a function. Okay, and this is good because functions, we can specify exactly what they should do. We can give a spec that says, here's the name of the function, here are the arguments it takes in, here's what it does, here's the value it returns. Okay, and this is what you encounter typically on the job. You're working on a project, you're not writing the whole program yourself. You're writing the function that, takes in this information about network traffic and does some analysis and generates this result. Or whatever. So your function in this case is a function called pick. It takes an integer, it returns an integer. What does it do? If that integer is a multiple of 4, it returns 1. Otherwise, it returns the remainder when you divide that integer by 4. Does that sound familiar in any way? Right? That's how you tell how many sticks the computer should pick if it's the computer's turn and there's n sticks left. So you can use this function in PA2 if you like. You may have already written it. But instead of putting that code in the middle of a loop, you can just call pick. It's computer's turn. There's n sticks left. How many sticks should the computer take? Pick parentheses n. Right? And the details that you have to do one if it's multiple 4 and all that, those are all hidden from you now. They're in this other function. And pick is just this much more powerful function that says, tell me how many sticks the computer should take. Okay, modularization, that's the whole goal for this course. Well, it's one of the goals for this course. Breaking things up into logical pieces. So pick's an example of that. But it's just a function. You cannot run pick. You cannot run square root. You cannot run fgets. Right? Those are functions. They're called by other functions. If you want to test your pick function, you need to write a main program that calls it. Because if you try to compile pick.c, it's going to say, well, there's no main program. So here's pick.c. And it's got, some integer pick. Integer, I'm just going to call it n, but you can call it something better. And it's going to do some stuff. And it's going to have some kind of return statement. And you got to figure out what the squiggly line should be. And if you want to know, does this compile successfully? Have I made any syntax errors? You can't just say gcc pick.c, because that's trying to build an executable. It's going to look for something named main, and there's nothing named main in here. The way you fix that is not by putting a main in here. Okay? Don't let the computer tell you what to do, right? I want to write a function, you're going to compile it. The way you tell the computer to do that is you put this -c switch. And it says compile, but don't build an executable. So this is compile only. Don't make an executable. All right, but you have to test your function before You go ahead and try to assess it. So you're going to write your own test program, and I'm just going to pretend it's called main.c. And here's going to be what our program looks like. And how are you going to test this pick function? It's up to you, okay? There's at least 3 quick ways that come to mind. One would be to take your command line argument and assume it's an integer, so run it through scanf, convert it to an int, pass that to pick, take the return value, print that out. Right? Another way would be to make a character array, pass it to fgets, print something like enter a number, have fgets wait for the user to type something in, take that string, run it through scanf, turn that into an integer, pass it to pick, print out the result. That's another option. Here's the easiest way to test pick. Something like this, printf, pick with an argument of 3 equals %d, comma, pick 3. One line of C code. And what does it ask to do? It asks to call the function pick with an argument of 3. That'll return an integer, and then print that integer out after printing pick_3 equals. And if I take this program and I compile it and I link it to pick.c and I execute it, it should generate one line of output, pick parentheses 3 equals, and I believe pick of 3 should return a 3. All right? So that would be one test. And then I could try pick of 4 and print out pick 4. And in this case, I believe it should say pick of 4 equals 1. Because pick does this weird thing. If your argument is divisible by 4, it prints out a 1. And I can either, keep making changes to this, compiling and running it, or, I could put 10 of these print statements in this program that pass different values, get some practice with VI, right? That's always a win. And have one program that should print out, pick of 17 equals, pick of 5 equals, pick of 7 equals, and so on. And I compile it, I link it, I run it, and I look at the output, and I say, yeah, my pick function works. Or, when it said pick of 4 equals, it printed out a 0 instead of a 1. Okay, I got a problem with pick. I'll go back into pick.c, make some changes, and redo this. Okay, but it's completely up to you how you want to test this function. But you want to test it. Okay, if you just assess it, you're going to get 10 out of 10 or 0 out of 10. It's not going to tell you anything except I've got a problem. I mean, you can try that if you feel lucky, because maybe it'll work. But you want to get in the habit of figuring out how to test functions, right? And this is what you're going to do when you're developing programs. If you're writing your stick matching program and you're modularizing, you're trying to develop small pieces and put them together, you write a piece that says how many sticks should the computer take, you call it pick.c, how do you test it? You write a main program, right? You don't put it into the whole PA2, which is 200 lines of code, and see if everything works, right? You write a program that just tests that one function. Test the heck out of it, all the possible cases you can imagine, and when it works, right, that's done. You don't have to think about it anymore. And you go on to your next function. Okay, this function asks the user how many sticks, and if they make a mistake, it'll do something. And if they put in the right number, it'll do something else, right? And you test that, and then that's done. And you build up like this. So this is an exercise in how you can be developing these larger programs, and we're going to do this throughout this course, throughout 222. Okay, so that's what these ODPs are reflecting. So what do we got? We got pick.c, you write that code, you compile it, there's no compilers, you write your test program. How do we execute our test program? gcc-o main program's name, pick program's name, and this will leave you with an executable called main, and then you can just go ahead and run that. If you wrote it to take command line arguments, you'd say main space in your command line arguments. If it's reading input while it runs, you'd say main enter, you type in your input, hit enter, and so on. It's your program. Okay, the only thing I'm specifying is the details of this function pick. So here's where it gets really different. Once you're done with this and you think that pick is complete and it's a good function and you want to assess it, how do you do that? You can't assess your main program. You can't just say assess main, because the assessment system has no idea what that's supposed to do, so it can't tell if it's doing the right thing or not. So I'm giving you a main program, and you're going to link your pick function to my main program and then assess that main program. Okay, and assess knows what that main program should do, so it can see if your pick function is doing the right thing. And it'll do something like this. It'll call pick with different values, take the return value, and see if it's actually, your number mod 4, possibly equal to 1. But I'm not going to give you the source code for the main program, because that would make things too easy. So I give you a compiled version of the main program, and that's this function /temp/odp410 main.o. So when you're ready to do your assessment, you do the following line. So this says C compiler, call the output file pick, compile my pick.c, and compile it with this test bed, this main program that's been supplied to me, /temp/odp410 main.o. That'll give you an executable program, pick. You can run pick if you like, but the output's not going to make any sense to you. Okay, the output is specific for the sake of assessing this. If you run the output, it's going to give you crazy stuff. Don't worry about that, right? You're not responsible for what this main program does. You're only responsible for the pick function. Okay, so you assess pick.c, do the usual assessment drill. Hopefully you get 10 out of 10. Right? Yes?
Does it matter which file goes first?
No. Just make sure you say -o followed by pick. Don't say -o pick.c, because then you clobber pick.c. But -o pick goes together, and then pick.c and temp. Those three things can go in any order. All right, so does that make sense so far? Okay, so let's talk about announcement 27. So because this is different from other ODPs, you're not writing a main program, et cetera, et cetera. So this is a more wordy version of what we've just said. It's a more wordy version of what's in the actual ODP 410 description. So all these different details. And if you already get it and you know what to do, don't worry about announcement 27. There's nothing extra in here that we haven't already said that's not already written in the ODP. But if you're having troubles getting this to work, right, here's a suggestion on how to get 100% on the assessment, okay? First thing, make sure you understand the assignment. How do you do that? Ideally, read the assignment before you get to class, okay? If there's no way to do that, we're going to talk about the assignment in class usually, okay? But you got to kind of tune in, you got to follow along, you got to think about what we're saying. And make sure you understand the goal of the assignment. Not necessarily how to do it, but the goal. Okay, you got to know what it's supposed to do before you figure out how to make it do that. So there's something about %4 and setting something equal to 1, and I don't really understand that. I'll send an email later. That's not your best strategy. Okay, because we're here right now. You got me at the front. You've got a room full of students, and if you're confused about something, guaranteed other people are also. Right? So take a chance and say, I don't get what you want this function pick to do. Is it supposed to print something or what? Right? And we'll talk about it in here. Right? That's your best chance for making sure you understand what the goal is here. Once we're apart and we're down to email, the bandwidth gets really small. Right? And I may or may not be successful in understanding your confusion, and you may or may not understand my explanation. And so this is the place to ideally figure out what the program's asking you to do. All right. Once you understand what the program should do, write code to do that. If you want to write flowcharts, if you want to write pseudocode, if you want to do whatever, right? But ultimately, you want to set a code that you call pick.c. That's your second step. And then test your code, right? So make a main program, compile it up, test it, make sure that works. debug it, retest it, keep iterating until you think pick.c is correct, and then build the assessment module. So do your gcc-o, pick's going to be the executable, link it in with the test bed, and then assess it. Okay, if you've done all of those things and your code is not assessing 10 out of 10, right, then you want to ask for help. And if you're going to send me an email, I will try to help you, but I need you to do some things in that email, okay? So first thing, so you're connected through PuTTY or SSH or something, cat space pick.c. Enter, that will show me what's in your pick.c file. I gotta have that, right? And then cat main.c, show me your test code. If you don't have a main.c, we can't really talk, right? Because my first question is going to be, so what did your test show? And if you haven't tested your code, right, there's very little that we can dialogue on meaningfully. So show me your test program, and then show me compiling it, right? Type in that compile line, hit enter. Because a lot of times, people show me their test code and they show me their assessment, and I can tell there's a syntax error in there, right? And when they tried to compile it, it must have given them a syntax error. But unless I can see that and say, take a look at the third line and tell me what you interpret that as, right? So go ahead and compile it and let it generate its messages. And then show me the execution of your test program. And then go ahead and compile it in with the test bed and show me your assess command and show me the G command and what assess gives you. And then all of that, starting with cat pick.c, grab that with your mouse, copy it, paste it plain text into an email, send it to me on macias@clark.edu. And then put on some words in the beginning, you know, what's going on, and so on and so forth. And that gives me something I can help you with. Okay. And if you send me a screenshot that's kind of fuzzy of some C code and you say, can you help me with this? I'm probably going to write back and say, see announcement 27. Okay? Which means that you probably need to do something in here. And if you're not getting it, I'll go ahead and I'll actually write you a response. But mostly I'm going to try to get you to do these things, and once we have these things, then we can actually like figure out what the source of the problem is, right? So I can say, you know, something that'll help point you in the direction, hopefully. Does that make sense? Okay, so I'll just leave it with that. And let me give you an example of what you should not probably do. And this is usually what people do first off. I'll put this on a page that says don't do this. Right? Guarantee I'll see code tonight that looks like this for pick.c, right? And this looks like most things that we've written in CSE 121 or even in this course so far, right? This is totally not what pick.c is asking for. So what's the first big issue with this pick.c? Yeah, what the heck is going to happen when I call my function and it gets to this line of code? It's going to stop, and it's going to wait for me to type something and hit enter, and then it's going to continue. So imagine if you wrote a piece of C code and you said y equals square root of x. And every time you called square root, your program stopped and waited for you to type something in and hit enter. That would be kind of a weird square root function, right? Same thing here. Or if you called square root and it printed a nice message saying, please enter a number. Make sure it's not negative. That's not a good square root function, right? Or if you called square root and square root printed out the square root of your number, right? And you got a program that's calling square root 10,000 times and it's printing out 10,000 numbers in the middle of your program, and you're like, what's going on here, right? Wouldn't be a very useful function. So we don't want to do these things unless the specification of our function is print out such and such or read such and such from the user, okay? But we're so used to doing this when we write programs that it's really hard not to put those in. Like, where am I going to put the scanf? I got to put it somewhere, right? Where do I put the print? There's no print in here. I can't turn this in, right? So those things will potentially trip you up. So go back to the specification. If it doesn't say print, don't print. Okay, if it doesn't say do something with input, don't do something with input and pick. Just reads an argument from the argument list that you pass to it, returns an integer. It's a silent function. Most of our functions will be silent. All right, switch gears, talk about some Unix. Yes?
When we do the programming assignment 2, can we make our functions separate like this, or do you want them all in the same?
I think it's vastly superior to make them separate. But if you want to put them in one file, I will not deduct points for that. That's perfectly fine also. But separate files is the way that we're going to be moving, and eventually we'll talk about how to break things into separate files and why we want to do that. And we'll talk about make files, which is how you can compile them more easily. So you're ahead of the curve if you do that. So a few random commands, and then I want to talk about efficiency. So I have a file in here called .bashrc. We talked about this the other day. This is where we put in stuff that we use to initialize things when we start bash. And if I want to see what's in there, I can say vi.bashrc, and I can scroll through my file. But vi is dangerous as a tool for viewing because it's an editor. And for example, I'm hitting Control-D to get down to the bottom of my file, and I might just hold down Control-D to repeat it, but if my finger slips off the control button and I just start hitting Ds without a control, I'm deleting files, deleting lines from my file, right? And I might not notice it. And I'll try to quit, and it'll say, oh, you haven't saved your changes, and I might go ahead and save those without thinking, right? So we don't usually want to use VI to look at files. But if we say cat, everything flies off the screen, right? And I got to start scrolling around, and scroll wheels are sometimes annoying. So a better way is to use the command more. And more is a way to look at a file one page at a time. So if I say more.bashrc or any file, it shows me one screen worth of contents of that file. And then at the bottom it says there's more. We're through 8% of this file. And I look at this, and if I want to go on to the next screen, I can hit a space bar, and there's the next chunk of output. And I can start scrolling through my file a whole page at a time, and if I'm looking for something, this is a quick way to go through. And if I think it's right after this, I can hit an enter and go down one line at a time. And if I really want to pop into VI, I can just hit a V, and it brings me into VI right at that point in my file. And when I exit VI, I'm right back where I was. And I can keep going, and I can search for things. I can say slash, show me the next line in my file that contains the word alias. And it says it's skipping, and then it shows me a few lines before, and then it shows me the next time that alias occurred in my file. And you can do all kinds of things inside more. And if you hit a question mark, it'll show you all the different commands you can use, right? So it's a much more powerful way to look at the contents of a file. And you can hit a Q to just get out of that. So the other option is less. And less is the same thing, but it's got more features. So it's kind of backwards. And when you get to the end of that, it doesn't exit, it just says end, and again, you hit a Q to get out of it. All right, and there's a lot of things in Unix that use more or less just by default. For example, the manual pages. When you say man gcc, that output's being run through the less command, which is why when you want to go through it, you can page through by a space. You can hit enter to go down one line at a time. You can search for things, and so on and so forth. And you hit a Q to get out. All right, so let's talk about efficiency. One of the goals in all of this stuff that we're talking about is to give you tools to help you be more efficient. Okay, the reason we have a whole course on Unix is not that Unix is so complex you need 11 weeks of listening to me talk about it. It's because Unix is a very good environment to be working in. It can be very efficient. It's everywhere, right? It's easy to put onto your own system. It's free, et cetera, but it really supports sort of an efficient work environment. So for example, there's a command called alias. This is one of the few commands that Bash actually understands. And the format of alias is alias space something new equals something old. And I'll give you an example. Suppose you grew up on an operating system where the way that you look at the list of files in your directory is the command dir. All right, so you, on DOS or something, you say dir enter and it shows you a list of files. And now you're on a Unix system and you got to do this thing that's not even a word, ls, to see the list of files. Right? So we can do the following. We can say alias dir equals ls. And now if I say dir, that's an abbreviation for ls. So I just made my own command. And maybe instead of trying to remember VI, because I've never heard of VI before, I want to use the word edit to mean VI. So now I can say edit haha, and it runs VI haha. Okay, is this going to like totally change your life? No. But it's not expensive either. It's there. And I can set up this alias in my .bash rc, and every time that I start bash, those aliases are there for me. So in my bash rc, I have a bunch of aliases set up already. For example, this. So several times a day, I want to execute ssh-p 50,000, et cetera, right? That's how I check the status of my job back at Virginia Tech. I don't want to type that in, ever. I did it a few times. It was painful. So I have an alias called VT. So any time that I'm want to hop over to the server, I just type VT. It executes that whole command, and it logs me into the server. Again, does that by itself make your life totally different? No. But it does two things. One, it saves me from having to remember this command and type it in every time that I want to hop over to this remote server. But more importantly, it doesn't distract me. Right? I'm writing some code, I'm making some changes, I want to go and execute it over on the tech server. I'm in a mindset where I'm coding, I'm debugging, I'm thinking, I'm creating. And all of a sudden, I got to open my notebook and say, now what's the address of that server? Oh yeah, www.right, and then I got to type it in and all this stuff, and I'm distracted. I'm no longer in my zone. My brain has been pulled onto another task that does me no good. Right? So here, I don't even have to think about it. I just say VT enter. And yeah, first few times I had to remember, but Virginia Tech, I always think of that as VT, so pretty quickly that just became second nature. That's what I do when I want to hop over to the server. And now I'm not being distracted, okay? That's the real goal of being able to tailor your environment, being able to customize things, being able to do things that make sense for you, is don't get distracted. Don't let things pull you away. So we're going to talk about a few things around this that can help make your life easier. I don't know if you caught this, but when I'm on the server over at VT, I have a slightly different prompt. My prompt begins with VT. Why? Because when I started hopping over all the time, I got confused sometimes. And I'd be like, okay, I'm just going to reload this archive, and I'd delete all my files, but guess what? I'm not on the VT server, I'm on my laptop, and I just wiped out all my files. Right? So I put a little prompt in there. Why? So I don't have to think. Right? I don't want to have to think in order to do the bidding of a computer. Okay? I want the computer to make my life easier. And when I'm thinking, I want it to be things that I want to spend my brain power on. I want it to be the creation. I want it to be whatever it is that I'm deciding I want to spend my life doing that moment. And I don't want to spend my time on other stuff. So you can set things up to make that happen. All right, so let's make a program. I don't know why I keep getting this error. Oh. All right, so you're writing your program, right? And you want to compile it up, and you do this GCC command, and you try your program, and it doesn't quite do what you want. So I want to go back and edit test2.c, and I'll go in there and I'll make some change, and then I want to recompile it. So you can type, right? But your goal is not to like get better at typing. Well, maybe it is, but your goal is to compile this program so you can test it and see if it works, and if not, go in and change it, right? Why should you spend your time typing a bunch of stuff just to tell the computer what to do? So you have a few options. You've probably discovered you can hit the up arrow and pull back previous commands, right? So you can do this and go back and find the GCC command and then just hit enter. But I gotta hit the up arrow and read what my previous commands were until I get to GCC. That's a bit of a pain. You might remember it's always 3 up arrows, but sometimes it's not, right? But I can also hit an exclamation mark followed by GCC, and that will find the last command I executed that started with GCC. And it'll go ahead and execute that. And if you look at history, right, history basically it goes backwards through your history and finds the first command in that list, so the latest command that starts with whatever you specified. So if I were to say exclamation mark A, it's going to go back and execute my alias command, because that was the last command that started with an A. So if I want to compile and I know I've only been doing GCC, VI, and main, right, I can just say exclamation G, and that'll do my compilation. And if I want to edit it, I can just say exclamation V, and it'll bring back my VI on test2.c. This is a little bit of a time saver, but it's mostly avoiding a distraction. So I can do that, and got to make another change. So yeah, I'm supposed to print this 4 times. I can compile, I can execute it. All right, so we're getting into a very rapid development cycle now. And the more you do this, the more it's going to become kind of ingrained, right? You can write scripts, right? You know how to write a shell script. Shell script, you can put a bunch of commands in. So I was developing some code. I was sitting on an airplane when I was doing this, And I had to compile a bunch of files together, and it was making an executable file called main, and then I wanted to run main. And I just made a shell script that basically does two things. It does this big long gcc-g-o main with all of these like things on the end, and then it echoes the word main, right? So I could say go enter, and it would print out the word main, and that was my reminder that my program was called main, and I should type in the command main now. But if it gave me compile errors, I could go back and do some editing and so on and so forth, right? So it took, 15 seconds to put this script together. And how did I put that script together? I did history. I found my GCC command. I copied it. I went into my Go program, and I just pasted it. All right, so that didn't take me a long time to do either. And then I didn't have to think about what I'm supposed to compile, like what do I have to include, and so on and so forth. So I invite you to sort of be open to these possibilities as they occur, right? And the first time you do this, it's going to take more time because you're going to have to remember how to do it, and there'll probably be some missteps and so on. But when you feel ambitious or like taking a chance, right, explore some of these things. And if it saves you a little bit of time, or it somehow strikes you as being kind of useful, right, you'll probably try it again. And eventually, if it works for you, it'll become second nature and it'll be part of your toolkit. If it doesn't, you won't use it, it'll go away, that's fine, right? But you'll discover for yourself these habits that can make life a little easier. Compile, and my compile's not working because there is no test2.c. Oh yeah, I called it test. So you can up arrow, and you can use the arrow keys to go back and make edits, right? And you probably know this. You can hit Control A to go to the beginning of a line. So if you want to change the command, if I misspelled GC and I wanted to say GCC, hit a Control A, that brings you to the beginning, and you can fix the command. Or I forgot something at the end, hit a Control E, that takes you to the end. And there's a ton of these shortcuts, but these are the two that I've mostly used, Control A and Control E. A takes you to the beginning, E takes you to the end. You can actually set up something in Bash so that when you go up with an up arrow, it understands VI commands. And you can move around as if you're in VI to edit this line. And I used to think that was cool, but it always messed me up. But there's lots of options. If you're typing a bunch of stuff and you just want to kind of like give up, Control U erases the whole line. If you're typing and you want to see what you typed, Control R says repeat the line. Oh, it seems to do something else too. But anyway, it repeats the line for you. And Control C always is like a quick give up, get out of here kind of thing.
So like the reverse search is really useful because you're able to find the last instance of the command that you
Yeah. You use Emacs, don't you?
No.
Oh, okay.
But it's just so useful because I work with Docker and just the complex Docker command.
Okay, cool.
Search for.
Okay. So there are all kinds of ways that you can sort of tailor your environment, right? So you use Docker. There's so many options out there, and sometimes you just want to kind of kick back and just sort of explore, right? Do some online research or just find some commands and try them, and you might find a totally different way of sort of living in a Unix environment. And you can lose yourself in that, right? That can end up being like the only thing you do, but if you got some free time, it's not a bad way to dig into stuff. All right, let me show you another one. So I want to build my program that I'm going to assess for ODP 410. So gcc-o pic.c, I know that, but I got to put in that weird file from /temp, all right? So /temp /ODP 410, what was it? It was main or something? I don't remember. Hit a tab. Log onto the server first. Right? Hit a tab, and it will try to complete your file name for you. So under /temp, the only thing that starts with ODP 410 is ODP 410 main.o. So I type in the beginning of this ODP 410, hit a tab, and it says, oh, there's only one file that this person could possibly mean, and it'll fill in that whole file for me. If I just type ODP and I hit a tab, it fills in a 4.1, but that's as far as it goes. And this means that I could have meant ODP 4.1, but it doesn't know what my next character was going to be. There must be more than one file. So hit tab twice and it'll show you a list of all the possible things that could match what you've typed so far. It's like, oh yeah, I wanted ODP 411. Well, I just got to type a single one to resolve that and hit a tab, and it'll complete it for me. And I know it completed because it put a space at the end. And this is a huge time saver, and I use this all the time up here. If you see me type really fast, that's what I'm doing. I'm just using tab completion. So if I want to execute something from /bin and I say /bin/ and I hit a tab twice, it'll say I could interpret that as 137 different possible things. Do you want to see all of them? And if I say yes, it'll show me all the things that I could have been planning to type. And this is coming through more, so I can go through it like that. And if I type /bin/g and I hit 2 tabs, there's exactly 5 commands that I might have been planning to type. And those are the only things in /bin that start with a G. So tab completion is really useful, right? It saves you from typing big, long, ridiculous sounding things over and over and over again. So in this area I've been working, I have a directory called all code. I made the C uppercase. I don't know why. I was on a plane. So I can just type cd space all tab, and it completes it for me, right? And if I want to know, is there a subdirectory under there, I can just hit 2 tabs. Oh yeah, I wanted to go into the backup directory, so I can type bac tab, and there's the rest of my line. And now I'm in my backup area. Again, you'll have to think about this and work with it and figure out what it's doing the first few times. But if you've got time, right, not 2 hours before your program's due, but if you got some time, you're just kind of chilling out, there's good music on and stuff, play around with the stuff, right? And eventually you'll find things like this that end up making your life easier. And it makes it fun, it makes it more fun to be working in this area, because you're in an environment that's very comfortable and familiar to you. And I can hop onto the CTEX server, and I can port my bash RC, and it's going to look just like my environment here. And if it doesn't, I can make it look like it. I can add something else in there to set something up. So when I VI my code, right, it all comes out in green. I don't have syntax highlighting turned on. There's another file called .exrc that lets me specify things that should happen when I run VI. And in there I have a command that says turn the syntax highlighting off. Right? Do you want syntax highlighting? You can have it turned on. So lots of opportunities like that. I don't have a Windows system booted up here, but same thing with PuTTY. You run PuTTY to connect to the server typically if you're on Windows, right? In your PuTTY session, there's a thing on that first screen that says default or default settings or something like that. You can change characteristics of your PuTTY session and say save this to my default. You can put in your username at linuxengrcs.com and save that to your default. And now when you open PuTTY, you can just hit enter, and it'll select the OK button, and it will take you to the password prompt. If you set up a secure connection, you can have it happen automatically. So for me, I just SSH, and I don't want to type nick@linux.engrcs.com, so I have Linux set up as a shortcut for that, and it does a handshake to authenticate, and it just logs me in. I never have to type a password. So what is Linux? It's just nick@linuxengrcs.com. And how did that come into existence? Because I have a line in my bash RC that says Linux equals nick@linuxengrcs.com.
Why does this thing have to be done in the bash RC?
You can do it anywhere. You can do it on the command line. Right, so now I can say comp, and that means GCC. Right, so use quotes if it's got spaces in it. So now if I say go, it means do all of that stuff. Right, that's another option for not having to type everything. Yeah,
Say if you want to get rid of an alias, do you just edit it in bash RC?
just unalias.
Oh, really? So-
If it's in your bash RC, you can take it out from there.
Okay.
But if it's in your current session, right, one way or another, you can just unalias your command. And if you want to see all of your aliases, just say alias, enter, and it shows you every alias that you've set up. So I have an encrypted file system on one of my drives, and when I want to mount it, I just say private. And private does all of this stuff, which I really don't want to have to type in. And I set that up like 15 years ago, and I don't even know what those things that I highlighted do anymore, right? I just know that I say private, enter, and it mounts up my file system. Asks me for a password. So PuTTY, right, you can have it automatically log in to the machine and the username of your choice. You can change the font, you can change the colors, you can set how many lines of scroll back you want. It defaults to like 1,000 or something really small, but you can set it to 100,000 lines of scroll back if you like. You can set all this stuff up in PuTTY, save it in your default settings, and now click on PuTTY, hit enter, and everything's ready to go. So things like that. All right, yes?
For the alias, can you use a command for the first word? Like, could you do something stupid like alias, unalias equals alias?
Yeah, yeah. So I just killed my alias command. And you could alias, unalias to something else, and then you couldn't unalias it.
Okay.
Yeah, you can do all kinds of things. It'll let you do it happily. You can also alias VI to be RM, but don't do that, friend. All right, so we'll talk about putting commands together next week. I will try to do a Git video over the weekend. I will try to get your SLPs graded over the weekend. Work on ODP 410. Let me know if you have issues with that. Work on PA2, and I will see you next week. Collaboratorium will be open tomorrow, so if you want to come and work on your labs or anything else, that's available. Have a good break.